In this video, we will do a simple model, just as usual. In the model, we will use a continuous spectrum. We will add it to a plane wave, incoherent plane wave, send this plane wave through a hole in a spherical mirror, and then the light will hit a grating, and the light will bounce between the grating and the spherical mirror back and forth. And we would like to see, what's what's happening here. Yeah, really, after a few reflections. So let's go on and create a new document. First thing is in the spectra folder, we can create a right-click, a new spectrum. There is multiple choices here. You can do Gaussian, which is like a typical LED, let's say. You can make a black body spectrum, like the sun or a bulb, and you can use a sampled spectrum, meaning you can add here multiple wavelength, and then the program will extrapolate or use the values in between. Yeah. Yeah, we'll just use the black body this time. All the other we can use we can keep it as it is. The other settings, and then we just click OK. Here's the spectrum. If I right click on it and say plot spectrum, that will show me the black body spectrum. That's something like the sun. The green is the maximum, and the visible range, which is really plotted here. So the spectrum we will use into a source. For that we will have to create a source, create new source primitive. We will use a incoherent plane wave, and this plane wave should be, let's say, 4x4 millimeter size. Can be circular, that's good. 1 watt of power. For now, 42 rays should do. I will just call it plane wave source, and we will select here the wavelength attributes, random according to spectrum, and the spectrum is selectable here from the list. I add it, and then immediately it automatically selects the minimum and the maximum value from the spectrum we have added. Let's make it red, because I like somehow red better than black. Click apply. Yeah, and we should have our source here. Yeah, there's not too many rays there though, 42, but that should do. So that's the source in there. As next, we will create the mirror. There's a spherical mirror. What we've been planning to do. So new mirror, create new mirror. This makes a mirror which this is a mirror spherical, let's call it, which is one side is mirrored. The material is made of glass. You can give the reflecting surface focal length. Let's say we can give it a focal length. What should we do? Let's try 50 for now. Yeah, the semi-diameter, semi-aperture is yeah, it should be quite large actually, because if you want to have the grating, the light from the grating diffraction, yeah, we should have it actually quite large. So that's what it is. Yeah, I can see immediately that. All right, okay. Now I thought I haven't given it any thickness, but yeah, thickness not much. Let's make it a bit larger, just to look like a real mirror. Right. So now we have our mirror. Unfortunately, that's still at the wrong position. So for like exactly in where the source is, so we will have to click here append and shift this like let's say 100. yeah, it doesn't matter because it's a plane wave. So yeah, we can just shift it like 100 away, 100 millimeters away, and we should also rotate it because I would like to have the grating somewhere here behind, and I would like the light to go through the mirror on a hole and hit there the grating somewhere. So to do that, I will add another line and select that it should be rotated about the x-axis 180 degrees, and yeah, that's what it is, 180 degrees. Now, how do we make a hole on this object? There is an option if you go on the mirror and click the surface, one of the surfaces. There's like a lot of options here which can be used. You can make the surface a grating. You can glue things to it. The thing we will use here is the tab aperture. At the aperture, there is like there's a thing called trimming volume. You can trim this this volume, yeah, of the you can trim this surface actually, and with other objects as well. And there is like a built-in option here that you can trim inner hole on it. I think our plane width was something like 2 millimeters times 2 millimeters. So I will give it 2 millimeters times 2 millimeters size, maybe even 2.5. And then you can see that there is suddenly a hole on it. Unfortunately, that's only the one side. So thread works with surfaces. That's not a bulk element really. It's just surfaces and surface boundaries. So as the rays would get hit this surface here from the source side, yeah, they would think that this is a glass, and then suddenly they hit here on this surface air, so error. We have to add the same hole on to the other side. So to do that, we have to go on the back surface. So select back surface, double click, and on the aperture we will add the same 2.5 millimeters semi-diameter aperture. Yeah, so that should do. If I now click trace, right, okay, so we're still far away actually, and the rays are not hitting any object, so that's why it's not traced any further. But to make this different, we will add something on the other side of this mirror, and we wanted to do a grating, so I would say we create a primitive element, and this time we will use only a plane, like a simple surface. We don't need anything complicated. Could use a block and just make one of the surfaces a grating, but we will just use this diffraction grating. It is grating. Yeah, there it is. The source was something like, what was it again, 2 millimeters, so we can make this 2.5 times 2.5 rectangular. That's quite usual for gratings. The position, it's at the source now. That's not good. We want to have it 2 times the focal length of this mirror. So I will reference it to the reflecting surface and add a distance in z direction. The mirror was 50 millimeters focal length. So if we want to have, the rays going back and forth, we will need double the focal length, so 100 here. Is that the thing? Did it move or did it not move? If I did minus? Alright, yeah, something was not. Oh yeah, okay, so of course 100 from there in the wrong direction is exactly at the source. Yeah, right. Okay, that's why it was confusing. Alright, so now we have our source and the plane. If I try to trace it now, you can see that the rays are nicely going through this hole, and it's hitting this plane surface. But it's not a grating yet. In fact, we haven't really defined what kind of thing it is. It can be made of air. It's already made of air. We would like it to reflect the light, so I will just make it reflect, and I will make the ray trace preference to reflect. So we want to only capture the reflected rays. If I click again ray trace, it won't make a difference because it's still not a grating. To make it a grating, the surface diffraction grating, I will have to click the surface again. And just like previously in this menu, there is like a tab here called grating. And it's quite self-explanatory what you can do here. If you just want to have, there's multiple options here. You can do like a lot of different kind of diffractive optical element. That's why I just use like a linear grating, evenly spaced lines. And just like gratings, you can add here, what's the frequency, the density of the lines, lines per millimeters. 100 sounds a bit, yeah, actually too small, but I don't think we will need anything larger than that because we're quite far still from this mirror. And what we will also have to do is to define, we'll have to define the diffraction efficiency. So how does the program know, where the power goes to, which diffraction orders, yeah, what you would like to simulate here. You will have to tell the program. If you just specify one wavelength, then it will be all the same. So for all the other wavelengths, you will get the same diffraction efficiency. You can add here other orders, not orders, but wavelengths. So that's what I mean. Yeah. So you can put here other wavelengths and give it a diffraction efficiency, but we won't do that. But we would like to have different diffraction orders. So I will click append order, and I would like to have the order 0. Yeah, why not? It's just backwards, but why not? And then I will add another order with right click always. It's quite handy. Always make these things larger, but they automatically don't appear that large. And yeah, we will have to also change the order here. You can change which diffraction order you want to use. We will use the 1, 0, and the -1 diffraction orders. It's a really simple thing here. I click apply, and if I click again ray trace, it should be the light should be going in multiple directions. So trace and render. Whoa. So yeah, what we can see here already is the effect of the light bouncing in every direction. So if I would turn off the spherical mirror, which is just right click and make it not traceable, then you can see that there's basically two directions, the plus and -1 diffraction order, and of course the 0 order, which is in work here. But if I add the mirror, then it's all going back and forth. I can see that that's what's happening here. Yeah, so the light is coming in, it's diffraction plus and -1 diffraction order. It's getting back, focus back on the grating, and from the +1 order, we'll go back to even larger order. Oh, wait a minute. How does this work? So yeah, so it will distribute again the power in every direction, but we're probably not in focus anyway, completely, and there will be always some spherical aberration. So yeah, there will be some light going at the side. If we would like to see this light, we can just add another element, so like something like a ring, I'm thinking, around this mirror. So let's just go on and add the new primitive element. It can be a simple plane again, because the plane always has this option to make it to make a hole on it. The hole, so yeah, let's make this quite big, so 40 times 40, and yeah, I think the hole should be something like 20. Of course, should be circular, and it should be referenced to the to this mirror instead of being referenced, yeah, to the other to the geometry 0 point. So here we go. If I click again trace, and now we can see more of these rays. You can also see that it's going in two directions mostly because of the orientation, obviously, of the grating. Now, yeah. So wait, let's call this like a detector ring, huh? And yeah, I would like to analyze what kind of you know, what kind of colors or what kind of distribution I get around this mirror. Then what would I do? I would add an analysis surface. So I would right click analysis surface, surfaces, and add new analysis surface. Let's give it some resolution, 250 maybe, I don't know. We shouldn't use too much because then we need too many of the arrays to trace it through. Size, I would say we make it like large, not auto size. Oh yeah, okay, so that's the thing. But as you can see, it's not attached to the surface yet. It's just floating somewhere. Analysis ring, let's call it. We still have to attach it to the ring, which is right click, attach analysis entity, and to the detector ring surface. Yeah, so now it works. Yeah, this is what it is. Now I'm really excited about this to see what's happening here. I don't know how this could be used actually, but it looks actually cool. I always like this periodic type of things, which just you know, you think you could go on infinitely, but you know, something is happening what you don't expect, and you know, the light is just going on the side instead of being reflected just back and forth. And yeah, I just find it amazing. So we would like to analyze this this model. To do that, we need to add a few more rays. Let's say how much? 500,000 rays, let's say. It should calculate quite quick. Let's see if it is enough. Oh yeah, that's gonna take some time. We don't want to wait that long. Let's make it a bit less, 200,000 maybe. All right. Okay, it is a little bit faster. So let's just wait it out and see what we get on this surface. Now the one function what we will use here is there is an option here. Yeah, so all these options go live when the ray trace is done. But you know, we can have a look. The one thing we would use is usually is the irradiance spread function, but we selected at the beginning that our whole spectra is in the visible. So there's an option here called color image, which will calculate the colors from the CIE chart. So the appearance, it would appear if you look at this ring, you know, with your eyes instead of a camera, or yeah. So that's what it is. We will see hopefully some kind of rainbow. Speaking of grating, so it's almost done. 98, 98, 99, and done. All right. So if I click color image and select the string, type of thing. Let's see what we get. Maybe the resolution is a bit too small. Yeah, I could have done it a bit better, a bit larger resolution. But yeah, so I can see definitely there's some kind of red going on, some white. Interesting that it's not exactly symmetric, but we did everything symmetric. I wonder what's causing that. Right. So yeah, food for thoughts. Food for thoughts. That's what it is. So we did the simulation. If you have more ideas how we could improve this, or you know how we could develop this further, then put it in the comments. Otherwise, it was a really good exercise for a few things, for the continuous spectrum, for defining a plane wave source, trimming a spherical mirror, adding a diffraction grating to the surface. Yeah, and of course using the color image option for the on the analysis options. So yeah, that's it. Thank you for watching and see you next time.